Hello, let us look at acids in chemistry. Of course, it's coming from the topic of acids, bases, and salts. And this is tutor PVS. All right, so it will be the whole lesson of acids. So we're just going to dive in and talk about acids themselves. All right, so let's first look at the definition. So I'll be writing in point form. So let's look at the definition number one. So, what is an acid? Okay, we define an acid as a chemical substance, not just a substance, but an acid is a chemical. It's a chemical substance, okay, which when dissolved in water, produces or releases what we call the hydrogen ions as the only positively charged ion. That is what an acid is. So this substance, you dissolve it in water, all right, it's going to release what we call the hydrogen ions. Now, these are the only positively charged ions that are formed in that water. All right, now, moving on, let's look at the types of acids. Types of acids. Okay. So acids can be classified based on their origin or composition, meaning we have only two types of acids. We have organic acids. Okay. We also have inorganic acids. So let's look at this. So what are organic acids? Organic acids, these are acids that contain carbon in their structure. All right? They contain carbon in their structure. Okay? What else? They are usually weak acids. They are usually weak acids. We'll talk about what weak acids are later on. All right. Can we give some examples of organic acids? All right. We have acetic acid, which is given by this formula, CH2COO, which is the one which is found in vinegar. We have ethanoic, this one is also known as ethanoic acid. We have got methanoic acid, we've got pentanoic acids. All those are organic acids. These are naturally found in organic compounds, for example. Next, we have inorganic. Inorganic, they are also known as, aka mineral acids. Mineral acids. They do not contain carbon. They do not contain carbon. And they are usually strong acids. Acids. So, meaning these, they occur the way they are in nature. All right? Just in nature like that. All right. Examples? We have the hydrochloric acid, the one that you know. Hydrochloric acid. We have the sulfuric acid. We have the nitric acid. These are some of the examples of what inorganic acids. Now we move on to point number 3, and I hope that you are following this lesson properly. All right. Okay, now let's look at classification of acids based on their strength. All right, you are going to look at classification of acids based on their strength. So based on strength, how many classes of acids are there? So we have strong acids. We have strong acids. Then we also have, let me call this one A. We also have weak acids. Weak acids. So let's talk about these. What are they? So strong acids are acids that completely ionize or dissociate in water, releasing a lot of hydrogen ions. So these, they completely ionize, or you can use the word dissociate, in water. All right, releasing many hydrogen ions. Okay, while these, they partially ionize in water. They partially ionize in water. Of course, instead of releasing many hydrogen ions, they release fewer hydrogen ions. Have you seen the difference? There's also a difference in terms of the amount of hydrogen ions which they release at the end of the dissociation or ionization process. All right, let's talk about their pH. All right, let's talk about, before I talk about their pH, they also conduct electricity quite well. All right, they conduct electricity very well, meaning these are strong electrolytes. All right, let's look at some examples. We have hydrochloric acid, we have sulfuric acid, we also have nitric acid. These are examples of strong acids. These, they conduct electricity poorly, meaning they're weak electrolytes. Examples. Examples? Can you give an examples? Acetic acid. Okay. Carbonic acid, which is given by H2. This is carbonic acid. So these are the two classes of acids. And we only classify acids based on their strength. Okay? Based on what? On their strength. Next, let us look at the properties of acids. Properties of acids. Number one, they have a sour taste. They have a sour taste. They taste sour. If you've tasted lemons before, I think you can attest to that. They turn blue litmus paper red. What else? They are corrosive, meaning they can react with anything and they can eat it, like they can eat it up like that. For example, when you put an acid on a cloth, it becomes eaten up. That's the corrosive effect of an acid. All right, they have a pH of less than 7. Those are acids, meaning pH 1 to 6. Those are acids. I hope that is clear. There are quite a number of properties. I've just mentioned a few, right? And most of these are just physical properties. Now we also have got the chemical properties of acids, all right? But we are going to branch them and look at acid reactions. So, acid reactions. We're going to look at categories of acids, of reaction that acids undergo. Number one, it's a reaction with metals. Acids can actually react with metals, but how do they react? So, when a metal reacts with an acid, they form a salt plus water. This process is important, all right, because there's water there being formed. For example, I can get a metal zinc, which is a solid. I can react this one with the hydrochloric acid, aqueous. This will give me zinc chloride, aqueous, plus hydrogen as a gas. Of course, we can just balance it up. Number two, neutralization reaction. Neutralization reaction. That is reaction with bases. So, how do acids react with bases? So, acids react with bases. So, when an acid plus base react together, they form a salt. What did I say? And hydrogen, sorry. Thank you. Salt plus water here. So, for example, if I get hydrochloric acid and sodium hydroxide, they are going to give me sodium chloride plus water. That's all. But you need to know that your equation should always be balanced and written with these state symbols. Right, together? Okay. Then we have reaction with carbonates. Reaction with carbonates. Acids can also react with carbonates. Exactly how? So when you have an acid and a carbonate reacting together, they always form a salt. They form water, and they also form carbon dioxide. For example, I can get hydrochloric acid. I react it with calcium carbonate, which is a solid. In this manner, I'm going to get calcium chloride. I'm also going to get water. I'm also going to get carbon dioxide, of which I just have to balance it up like that. Next is point number 6. Number 6 is uses of acids. Okay, for example, hydrochloric acid. Where is it used? All right, we have digestion. In your stomach, there is hydrochloric acid. All right, it's also used in cleaning of metals. What about sulfuric acid? This is a symbol for sulfuric acid, the chemical formula. It's also used in the manufacture of fertilizer. Also used in car batteries. Nitric acid. Nitric acid. Nitric acid is used, number one, in explosives, also in fertilizers. Acetic acid, the one we call vinegar, the one which is found in vinegar, right? The one which is acetic acid, which is the ethanoic acid, the one which is found in vinegar. It is used for food as food preservative, for example, vinegar. Now, perfect. Now, this completes acids, but we have the pH scale, we have the indicators. Those are just the overall component of acid, bases, and salts. So, in terms of acids, we are done. So this is just a well-made video, all right, on how we teach, and I hope that you enjoy this video, and I wish you luck.